This is over. Yeah. So nature creates the sun. So basically, my field is related to the solar energy. The many applications of solar energy: low temperature, medium temperature, and high temperature. So and we are I'm very much blessed with this God sun also. And in fact, the sun is only the ultimate source of energy for this planet, the eco-friendly or the clean energy source, right? So this is, so basically, before starting my this talk on the solar drawing, just like, solar drawing is not a new concept. We are practicing from the ancient time, but now we are more rely on our conventional energy, like in that for the instant drawing and all. But just give you some background on the why the solar energy is needed for the domestic as well as the commercial and the industrial purposes also. So now, basically, the if energy sectors, we can classify the domestic, transportation, agriculture, and industry sector, right? So more and more energy consumption in this sector means the more and more facility we are availing. Oh, whether it is a domestic, I remember a long time now the convection, this microwave oven is very common to all the household. Okay, so this and the better transport facility like metro and all. So like industry, this agriculture sector, the new farm machinery we are using for the enhancing our production rate, and industry also, because for any country, for the industrial development is needed for the its own development, fine. So now this basically for the advancement, modernization, and economic evaluation for any nation, we need to have the more and more share into the industrial energy uses, fine. So this figure basically gives us some idea regarding the 10 developing and developed country. There, see, the energy uses almost 70. Of course, we know that China is the highest energy consumer right now, and out of that, whatever the energy they consume, the most of the energy they consume in their industrial development only. Almost 70% of energy, whatever the energy they consume, it goes into the industrial sector only. And on an average, the 30 to 35% of energy in the rest of the world, like in that way. So, like USA is consuming only 33%. That doesn't mean they stop, they slow down their industrial progress and all. It is that depends on the energy efficiency also, right? Yeah, these are the much correlated. So and in fact, for the industrial energy consumption, as we know from our previous figure, the 32% of industrial energy consumption is there on an average worldwide, and out of that, the 74% of the industrial consumption is used to meet the process heat demand, and the process heat demand we can classify based on the temperature, the process heat demand into low temperature, medium temperature, and high temperature. Fine. So low temperature is up to the 150 degrees centigrade, and the medium temperature 150 to 400 degrees centigrade, and the high temperature process heat application more than 400 degrees centigrade. So sometimes we think for solar energy is not applicable for the industrial purposes. Fine. So, but we can easily achieve this 150 degree temperature or up to the 400 degree temperature with the help of the solar thermal devices, solar thermal energy conversion devices. In as far as concerned with our industry, so in developing country we have the agriculture, textile, pharmaceutical, food processing, dairy, brick industry. These are the basically main subsectors, and the drying, boiling, washing, sterilizing, pasteurization. These are the main processes where in these. Okay, so energy consumption and emissions. There are more and more energy consumption means the more and more emissions are there. Right. So and in fact, solar energy we can apply for the drying purposes and some other applications also for the steel, glass, ceramic industry also. Right. So. Like I have already told you that this pressurization, sterilization, drying, concentration, and dairy, tin food, paper, textile, chemical, meat, beverage, and these are the some industries where the drying operations are taking place. So a very common drying operation. Okay, so and yeah, so just have a look on this slide, the drying, tin, paper, textile industry. Just to see over there. the maximum temperature is required for the different applications, whether it is the drying, concentration, pasteurization. This is not more than the 120 degrees centigrade. Okay, so that I want to just highlight over here. Most of our operations, whether the drying, sterilization, pasteurization, cooking, bleaching, these are just within the 200 degrees centigrade, within the 200 degrees centigrade, right? So, and there the this is the FPC flat plate collector, evacuative collector ETC, and CPC's compound parabolic compound collectors, right? LFR linear fractional collectors. These are the different in a solar thermal energy conversion technology, and these are sufficient to provide this much of temperature of range, right? So now the for the drying for in UK and France, some developing country, just see over there how much share of the drying in that particular in their country, in their industrial energy consumptions. Suppose the food and agriculture, the France and British, France in the industry drying and the British industry drying, the total percentage is 12%. 12% of the total energy consumption goes into the drying applications only, like in the chemical, 6%, textile 5%, and papers in the third. Papers are 33%. A lot of energy is required for the drying operation in the paper industry. Ceramic building and 11%, and on an average, we can say the almost 17% of the whatever the energy is consumed in the industrial sector, that goes to the drying operation only. So that and drying whatever the drying takes place and not more than the 120 degrees centigrade. And in really for the paper in the paper industry, the drying is taking place in the indirect way. Okay, so there we need the temperature is around the 160 degree temperature around, right? For the roller, and the drums are we use for steam drying with the help of the steams we generally use over there. But in overall, not so this is the basically. So this is drying. You may see the textile industry also, the energy requirement in the textile bed process. So over here, just to see over there in the drying operations. Okay, yeah, in the drying operation, the steam cylinders are used for textile industry, 2.5 to 4.5 gigajoule per tons output. This much of energy consumption over there, fine, up to the 7.5 gigajoule per tons of the output. So, and all this drying process in the textile industry taking place at 160 degrees centigrade, not more than the 160 to 170 degrees centigrade, not more than that, indirect drying, right? And so this in the Japan is the most developed country, or comes under the developed country, and the share of the total thermal energy in case of the product drying, let's just see over there the 17.2%, right? So whatever the energy consumed in their industrial sector, almost the 17.2% energy on an average goes into the drying operation only. So that drying operation energy consumed in the drying operation, that we can incorporate with the help of, or that replacement we can do partially, or some in some application we can replace with the solar energy and with the help of the energy storage system, fine. So just look at over here, the 1/3 of the total global emissions are released by the industrial sector only. 1/3 is the serious issue, and the emission raised by an average of the 1.5% each year during the 1971 and to the 2004. And I believe this 1.5 is not decreased. In fact, it would be increased only. Fine. Although this is an old figure, 175 to 2004, but still this emissions rate is not less than the 1.5%. Fine. So now come to this was this all about was just to say the solar drying before the how the this drying operations in the industry, how we can replace with the solar energy. So anyway, so this solar drying, in fact the food drying just is demand for the food is predicted by the 40 to 50% by the 2030, and there are many losses are there during the harvesting and the post harvest losses that we can avoid with the help of the solar drying. And right, And there are many kind. We can reduce the moisture contains of the agriculture produce by the drying, refrigeration, salting, and many kinds of the way are there. And but they are very energy intensive. Okay, lot of energy is need to consume for extracting the moisture content in the food contents, whether it is the crop or the fruit or okay. So and right. So we can say that whatever the losses, post harvest losses are there with the help of the solar drying and for the later uses, right? So in drying operation, basically it is a moisture removal is taking place up to the safe moisture level. Okay, I will show you in my next slide the fruits and vegetables. They are having some there is some limitation or the some safe moisture limits are over there. Okay, so this much of moisture removal is required, whether wet vessels or the dry vessels. That is the major way of the measurement of the moisture contains over there. And and basically, if suppose the moisture contains is higher than it's more than its desired level, definitely microbiological instability will be there. Okay, and so rate of the drying product can be improved by controlling the manufacturer, the solar radiation, humidity, and velocity. And in fact, in the drying operations, there are three factors are mainly responsible: temperature, relative humidity, and the airflow over the agriculture produce or that object to be dried, right? So we have to control the three factors: temperature, relative humidity, and flow rate, right? So based on that, of course, the solar radiation, humidity, wind energy, good solar radiations are needed over there. And solar drying preserves the food, agriculture product, domestic, industrial sector. It enhances the food and storage capacity, protection from the environmental impact, reduces the. Okay. So this open sun drying, what we do over there, just we spread the agriculture produces over their crop, vegetable, or fruits, whatever we want to reduce its moisture content on the floor. The solar radiations are coming, and the short wave radiations are coming over here and falling on the surface of the food product, and its temperature increases, and because of the pressure difference between the surface and just above the surface, the moisture evaporation starts. Okay, so this is the simple, but it has some problem because you cannot control its quality because discoloration will be there. Okay, so now the people are very conscious about the color, texture, and its stuffiness. Okay, the hardness also matters. So some quality factors we need to take care for during the drying operation. So in fact, this open sun drying, we have some problems, and in fact over there we cannot control the drying parameters. We cannot control the temperature, we cannot control the relative humidity, and in fact most of the food products are of the hygroscopic nature. Okay, so after certain time, if suppose the relative humidity of the surrounding atmosphere is higher, then what will happen? It start absorbing. Okay, so so that is equilibrium moisture content is very important factor for that. We have to be very much we should take care during the end product drying. Okay, so these limitations, and okay, fine. Now just look at over there, banana, pea, logan, many crops are there, the wild ginger, chili, coffee, rice, maize, and mango, pear, and just to see the initial moisture contains and the final moisture content. And this final moisture, this is the safe moisture contains basically, and this drying time is for the solar drying. Okay, this is for the solar drying. This has been reported by the various researcher. Okay, so but in fact we want to dry the product in the shortest time. So that means we need the faster drying rate. Okay, So that is our because and many crops, many crops, vegetables, they started deteriorate after some time. Okay, so to avoid that, we have to maintain the faster drying rate also. At the same time, we cannot increase the temperature. Okay, if suppose the temperature is increased in some of the crops, in some of the fruit or vegetables, if suppose we exceed the temperature of the whatever the desired temperature is there, definitely nutrients value will decrease. Okay, we lost its nutrient value. So we have to be very much careful about its operating temperature also, the drying temperature or the drying air temperature, right? These are some products from the seaweed, red seaweed, lemon, olive oil, okay, some fish and all like that. So yeah, it can be classified. The solar drying system can be classified uh, like the open sun drying. Okay, this is the traditional conventional drying. Okay, fine, and it can be classified direct, indirect, and hybrid dryer. So basically, this is direct, indirect, and hybrid drying dryer classification. This classification is based on the exposure of the solar radiations. Whether the direct exposure of the solar radiation of the crop is there, then greenhouse and direct type drying, direct type of the greenhouse dryer are there, and indirect means the first we are using some device, the collector, the flat plate collector or evacuate collector or any kind of collector uh, to um, uh, to heat up the ambient air, and then the hot air is passed to the drying chamber. Okay, so this is another one way. And the hybrid dryers are, these are the ways basically, if suppose we are using some another source of energy other than this solar energy. If suppose solar thermal energy, the solar photovoltaic system sometimes we use for the creating the drought. Okay, so creating the pressure difference to for removal of the hot and humid air from the drying chamber. Okay, and at the same time, sometimes we use the storage media also, because sun is an independent source of energy, and during the daytime it is fine. If suppose we want continuous drying, then definitely we need the solar storage devices also. So direct, indirect, and hybrid drying systems, these are the classification based on the how the exposure of the agriculture produce or the object to be dried over there. And this active and passive mode. Active means forced convection mode, and passive means natural convection. And because of the this thermosiphon effect, the movement of the hot and humid air and the fresh air is basically because of the thermosiphon effect. That is the this natural convection and the passive mode. Okay, and in fact, in for the high moisture content crop, definitely we need the faster means we need to maintain its relative humidity inside the drying chamber. So we need to remove the hot and humid air continuously. Okay, and even if suppose the relative humidity keeps on increasing and we are increasing the temperature also, that means the drying will not take place. Okay, so so this is the mode this airflow mode, right? The way the airflow, how the airflow is there in the drying chamber. Based on that, we can classify the solar dryer active and passive mode, the dry and dry. So this is the broad way you can classify. Okay. Okay. So solar drying is generally classified to, this is over, natural, close. Okay, all type of the solar operating two mode. This is okay, fine. Yeah, this is the example for the active and passive mode. Okay. Now, in this first, in the passive mode, we are the ventilation is over there on the top of the roof. And the fresh air is coming through this way, and it is get heated, and when it comes into contact with this crop, this is cabbage. I think the cabbage flakes are there over there inside and outside the open sun drying, and then this is the greenhouse drying is there. Okay, so the hot and humid air is taking place because of the thermosiphon effect. It is really it is come out through this exhaust ventilations. Okay, and for the high moisture content, definitely you need to drag out continuously the hot and humid air. For that we need some fan, blower, okay, some pumping system, some pump is required for the industrial drying case. Over here, the PV modules are attached. Then this system, you can say this is a kind of hybrid system. It is this DC fan is be attached, and DC fans are running through the power, whatever the power it produces with the help of this PV modules. Okay, this is the hybrid and active mode. Fine. And this kind of drying systems are very useful for the high moisture content crop. Okay. So now direct, indirect, hybrid, this is over. Yes. In the broad way, just you look at over here. Yeah, that I have the movement of the air inside that is passive and active, the product exposure to this is the direct, indirect, and the hybrid mixed mode and all. Okay. And now this is the broad way you can classify the natural convection mode and the forced convection mode, and further this is the sensible heat waste and the latent heat waste. And for the sensible heat, rock, concrete, gravels, sand, these items you can use for the sensible heat storage media, these media basically. And the latent heat, the organic and the paraphonic, glycol, etc. For the inorganic, the calcium chloride, hexaglide, sodium sulfate, and the decahydrate. So these are the latent heat storage media that you can apply. That depends on which kind of the crop is the solar drying system is designed for some specific type of crop. Okay, so based on that only, how much temperature is required during the drying and how long it is required, and the whether it is the constant is fine, constant rate of constant we need to maintain the constant temperature inside the drying chamber. So that all depends on the type, which kind of the storage media is required over there. Okay. So then further the sense based on sensible or latent heat, the direct, indirect, mixed mode. In mixed mode, the direct and this is the fusion of direct and indirect, and the hybrid. Different kind of the energy sources we can use in the drying system. Okay. In the drying, the cabinet and greenhouse drying, like sir was saying, Anil has developed one model, and we have developed one drying drying kinetic model basically for the greenhouse drying systems, right? So and then the further this is the cabinet type, the cabinet type dryer or cabinet solar drying system. Long back people were using, and even today the some tribal area people are using the cabinet type dryer also. Okay, for greenhouse drying systems are basically useful for the bulk drying. Okay, so this bulk drying and in fact utilization of the solar energy can be effectively improved with the help of this types of the flow, whether this is bare end, concrete, black painted, black PVC covered sheets, rock, wet, and sand flow. We have one patent based on that itself. We have designed the greenhouse system integrated with the solar collector, and solar collector, this was a purely indigenous technology, and in fact nothing whatever the locally available material based on that we have fabricated that collector, and it is almost about to grant, and very soon I'm just waiting for to listen that news. Okay, so in our patent the design of this design of greenhouse system, we have used there this one solar air heating collectors we have used. So this is a glazing material. Glazing material can be the polythene, polycarbonate sheet, glass, because glass is fragile material, and to handle is sometimes difficult. Okay, so and in fact its cost is higher. So this all these we can compensate with the help of the polycarbonate sheet. Okay, fiberglass is also. So now these days the good quality of the polycarbonate sheets are available with those are having the good transmissivity. Okay, so now based on the structure, the single slope, double slope, dual slope, parabolic, chapel, tunnel type. Okay, that all depends on the which kind of the means the different kind of the shapes could be there, and they have definitely shape or structure impact on the airflow also. Okay, so this is another very important factor to for this okay this shape of the structure of the greenhouse dryer. And north wall insulated, because what happened if suppose greenhouse is oriented with the north south, sorry, if it is oriented the east-west position, and what will happen if sun is moving from the east to west, okay, and face towards the south, and what will happen if suppose the transparent wall is there, if suppose north wall is the transparent, then what will happen, most of the solar radiation comes from the solar the south wall and passing directly passing through the north wall, and these are basically losses basically. Okay? Those losses we can trap or we can stop with the help of by making the opaque north wall, and this north wall we can in this north wall we can utilize the energy storage material effectively. Okay, energy storage material. Yeah,
Full slide. Now it is final. It is. Next slide.
This one?
Next slide. No, this slide.
No, sir. I was discussing this one now. Classification.
You start.
Yeah.
Next one.
Yes. So I was talking about this solar drying system, natural convection force and civil heat and all. Okay, direct, indirect, and all. So basically, this direct is the cabinet type, and the indirect is indirect greenhouse type system. And this greenhouse are generally used for the cultivation purpose. Okay, the favorable environmental, favorable condition you can maintain in the greenhouse for the cultivation purpose. But the later people have realized, because in the few months it is ideal condition. So make it more effective, make it more whatever rate of return could be higher to utilize during the off season of the like. So later on the people realized this greenhouse could be used for the drying system for the bulk drying. Okay, so and later on some modification has been done basically in the design itself for the purpose of the drying only. So type of the floor, it could be barren, concrete, black painted, black PVC covered, rock bed, sand floor. Definitely the type of the floor and the color of the floor is affect the solar radiation's utility. Okay, so we can maximize the solar energy, maximum use of the solar energy with the help of the it increases its absorptivity and storage in the sensible heat media and all. Okay, so glazing, the transmissivity, solar radiation transmissivity, this for canopy purpose, the glaze material, the polythene sheet, the polycarbonate sheet, this is for the covering the greenhouse system. It is very okay. So earlier we were using the glass, but it is a fragile material, and for breaking and all, some problems are associated with that. And in fact, the cost was also another factor for you to avoid this glass. Now the polycarbonate sheet and some polycarbonate sheet, the polymers are of having the good mechanical property, mechanical as well as the optical properties. Okay, so these are being used. Okay, the structure, the single roof, double roof, chapel, dwell, parabolic, and of course this shape is also very much important for the purpose of the airflow. Basically, proper airflow or the uniform airflow is responsible for the proper structure of the greenhouse. And the north wall is insulated or uninsulated, or it is transparent. So what happened if suppose the greenhouse is east-west orientation is there, and sun is moving from the east to west direction and facing the south basically. Okay, so what happened, the most of the solar radiation during before noon and the afternoon, so most of the radiations are passing through the north wall. Okay, so this is basically the some kind of loss is there, so that we can avoid by making the opaque north wall. And by making our north wall, or we can use the in the north wall this energy storage materials we can apply in the north wall itself. Okay, so so during the option are, what will happen, the energy heat energy will be released through that north insulated wall itself. Okay, so now, so this indirect solar dryer is also there. Indirect means the solar the air is being heat in some solar air heating collector, and then supply into the the drying chambers. Okay, and so again this energy storage with the heat exchanger we are using. So this is another way for the indirect for to apply the energy storage material into the indirect solar drying system. The solar water heating based on the water air heat exchangers. So based on that, we have developed one solar drying system. I will discuss you in my lab only. We have based on that. So so over here, the non-concentrating collector, flat plate, evacuated compound, parabolic, cylindrical, that depends on the how much temperature is needed. Okay, if suppose the industrial for some for the industrial purpose, definitely we need the high temperature that we can achieve with the help of the parabolic and the linear fractional or parabolic disk and the heliostatic type of reflector. Now the mixed type means it is the fusion of direct and indirect. So the cabinet at the same time, what happened in the mixed type, the hot air supplying to the solar collector, and at the same time the direct radiations are also there. I will show you over there. Okay, the greenhouse is also coupled with the solar air collector. Okay, this is another example of the mixed type. And hybrid means some other kind of the energy resources we are using in the drying system, solar drying system. So it could be a PVT type system, PVT. Okay, the PV systems are basically used for the running the blower or the exhaust fan and all. Okay, and this kind of the application are very much useful for the remote area where the non-grid electricity is not supplied for the grid. Okay, through the grid. So the thermal storage assist system, of course, this also comes under the category of hybrid. LPG assist system, electric air heating assisted system. And because during the cloudy weathers, like for India, we have almost the 60 days, and most of the part, and almost the 60 days we have the cloudy or the hazy weather. So during that time, we do not have sufficient the solar radiation. So we need to have some auxiliary systems. Okay, so these are. But for example, if suppose we are drying the banana, when I was in Thailand, we have constructed one banana drying system. So there, through we want to actually design a banana drying system where the conventional energy is not being used. Okay, so for that purpose, what happens? So with the help of the banana peel, we develop the bioenergy, and through the heat exchanger, the hot air is supplying with the help of that. I have not included. So there are the different component in the solar drying systems: the collector, drying chamber, and auxiliary system. Okay, so collector, solar collector for the indirect solar drying system. This drying chamber. Okay, and the auxiliary system for the cloudy weathers and all. We need some auxiliary system, whether the electrical conventional based, LPG based, or the storage. Okay, drying chamber, the box type, cabinet, tunnel, and greenhouse roof integrated chimney. And the non-concentrating flat, evacuated, compound, parabolic, and all these are the solar thermal energy conversion technology. Okay, the storage, thermochemical, essential heat, liquid, solid, latent heat, absorption, phase change material, and all. Okay, the hybrid drying system, solar hybrid drying system could have the storage, the biomass, electrical, and these are all. Okay, so now, okay. Let me come to this. Just I am showing you over here. This is the basically the direct type system. So solar radiation is coming and passing through this transparent canopy basically, or it could be the glass or the polycarbonate sheet and whatever. The solar radiation in the form of the short wave radiations are coming and falling on this whatever the crop or the agriculture produces spread over there on the tray. And gradually the temperature of this crop, whatever the product is there, and its temperature is keeps on increasing, and evaporation starts over there. Okay, and this chimney is over there for this is the creating the draught for the passive. Basically, this is the passive kind of the solar drying system, passive direct drying system. Okay, this is the another. And for example, some author have done work on that. And this is the indirect type system. And we have also developed in our lab, one of my scholar, Vijayan, he has done good work on this kind of system. Only the drawback of this kind of system is, if suppose we are applying the blower is over there, then a lot of pressure drop is there. Okay, a lot of energy consumption is there, and that we can avoid if suppose we are applying the pumping system or the exhaust over here. Okay, so in fact this is the solar flat collector, and over there this is the storage the storage media, the sensitive heat or the facial material you can use over there. Or here they have used the gravels. Gravels are basically used for the sensitive heat storage, and blower for the force, because a lot of pressure drop is over there. Okay, so gravels, and in fact this collector also we can design more effectively with the help of to increase its roughness. Okay, so that way we can use, and this is the drying chamber where we have the different gauge 1, 2, 3, 4, whatever, that based on the capacity of the drying system. Okay, this is drying chamber. This dryer is designed for the chili, basically loading and unloading over there. And this is insulated, because this drying chamber is insulated over here. Okay, is to avoid any heat losses, and the hot and humid air is passed through this exit, the humid air exit, and this vent. And okay, so this is the one way. Indirect type. Many authors have done and mixed mode. Now let us see. Over here, this is the mixed mode. So this is the PVT system. The PV cells are over there in the on that side, I think. Yeah. Okay. So this is the PVT system, the mixed mode developed by the faster drying rate with combination of both the direct and indirect. So the dryer, mostly the hybrid dryer operated in active mode. Okay, PV cells are they stick on this surface. Okay, and in fact they have designed this biomass heat exchanger basically. Okay, so this PV and biomass, this is the biomass heat exchanger also over here. Okay, and now yeah. So in drying, basically this is very important curve. Okay, if we want to understand what is happening in the when the moisture evaporation is there from the agriculture produce to the environment. So basically this A-AB, this is the representative warming up period. Okay, that depends on the nature of the crop. Okay, so during this period the temperature of the product increases due to the supply of heat energy, and subsequently the product surface is cooled due to the evaporation of the moisture content. So means the heating and the subsequent cooling of the product get stabilized after some time period. Okay, so temperature of the product remains constant over this period. Okay, so now over this period. So now this is the BC. This is the constant drying period. Over there, in this period, the evaporation per unit surface area takes place. The constant rate occurs when the water at the surface of the product get evaporated and get replaced by the migration of the water molecule from the product to the surface, from the inner to the core to the surface. Basically, the diffusion also takes place at the same time from the moisture from the core to the surface also. Okay, so this is the constant drying period. Okay, and in fact, the C represent the end of the constant drying period, the first critical moisture contained. Okay, then it comes. This is the CD is the falling rate. Okay, so first falling rate. This is the first falling rate. This is the second falling rate. Okay, so in the first falling rate, when the water at the surface is depleted, and the capillary forces stop the migration of water on the surface. Fine. The moisture diffusion controlled by the initial internal liquid movement within the product. During this product, drying rate reduced continuously. Okay, because most of the moisture is evaporated up to the D point over there. This is the this is second falling rate. D represents second critical moisture contained over there. D represents second falling rate. Okay, and this E is basically equilibrium moisture contained, and this equilibrium moisture contained is very important factor. I think sir is calling. I have sir. Sir, I'm connected or not?
Anil, you are connected.
Okay, fine. So because right, sir. So this is equilibrium moisture contained. This point is very important because and Hazelberg have given one equation, and in fact we have also developed one equation for that for rubber drying product. Okay, because time is not sufficient. So, and in fact there are some few factors which we have to consider during the drawing and during performance evaluation of any drawing system. Okay, so moisture content, it could be the dry basis, it could be the wet basis. When we are considering the bone over there, uh, 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 denominator. Okay, if suppose it's mi is the bone dry is we are considering over here at this place, then this term is known as the dry basis moisture content. And if suppose the total moisture contains over there or the instant basically, so that is basically the wet basis. Okay, we can take any one type of the moisture content, because in the moisture ratio that will be nullified. This moisture ratio, the effective value will be with the one only. Fine. So in most of the research, what will happen, the equilibrium moisture content, to make it easy the analysis, they generally consider this equilibrium moisture contains, the value of the equilibrium moisture content is very low as compared to initial moisture content. Okay, so generally what we to make easy this exercise, we generally they generally what they do, they assume this is very negligible, this is 0, so m and m naught. So this the initial, this is the moisture content, this m is the moisture content at any instant of the time, and this is the initial moisture content. However, this is the wrong practice. We should consider the moisture in this moisture equilibrium moisture content always. We should always consider this term, because if suppose the high moisture content crop is there, and in that case the equilibrium moisture content could be very less. But if suppose the moisture content of the crop is the rubber sheet, if suppose rubber sheet, and the maximum moisture content of initial moisture content is around the 40%, 38%, and we need to reduce it by the 0.6%. Okay, so in that initial moisture content is also not very high. Okay, it is not it is less than 50 or the 40% only. So in that case, it is very necessary to consider the ME. For that equilibrium moisture content, we need to establish one equation for the equilibrium moisture content with the and this equation is having the temperature as well as the relative humidity. Okay, I will show you. We have considered in our recent one paper. Okay, so this is a drying rate. Basically, the drying rate indicates the graphical representation time and the moisture content at this coordinate. So whatever the moisture is removed during the time t, that is a drying rate. And in fact, our aim is to enhance this value as much as possible, but we have some limitations also. Okay, so drying efficiency, this is the total moisture evaporated and this solar radiation falling on the surface area. It gives the drying efficiency. Okay, so like in that way, these are the few fundamental things we have to we need to calculate during the for evaluating the performance of any solar drying system. Okay, so this is for the indirect solar drying system. Okay, so pressure drop, and these terms are also very important for in case of the passive design of the drying system. Fine. So so this is mass of the flow, and then from total heat gained by the air and mixed mode. Just few fundamental. Okay, now just I want to come. How much time I have? Okay, so
Anil, this is 15 minutes.
15, sir. Okay, sir. Okay. So I would like to now come to my work only. So this is just to see over here. This is the dryer with opaque north valve. Okay, as I was talking about, we have done some we have applied for the patent and it is about to grant. And what is the specialty of that? Because we have designed this special kind of this collector over there. So the collector, okay, and this is the locally available. This was made by the locally available polythene sheet, and we have maintained some gap over there. That gap we have initially we have just designed by taking some gap, but later on we have already optimized this gap and the diameter and how much diameter should be there. These are the double layer basically polythene sheet. Okay, at the bottom we have spread at the bottom, and this drying tray is hanging in the mid of this central height over there, and this is the this was the north wall, and it was opaque with the reflective surface. Okay, and this over on the top is the ventilation for removing what is called hot and humid air. Okay, so and if suppose this is the passive mode, and if for the active mode, what we have done, we kept over there one fan over there, and this was closed by the time. Okay, and we also attach few solar cell over there. For the few solar cell means, as per the design and for the requirement of the whatever the power consumed for power consumed by this small fan. This is DC fan was there, and the charge controller we have arranged over there itself on this side only. Okay, so this was now. Okay, this was another. Now come to my work. I just want to turn. This I have already discussed. Yes. This drying system we have recently designed, and this is basically the based on the this evacuative assisted solar drying system. And over here, just to see, water jackets are water tubes are over there, and on that this drying tray are resides over there. Okay, so heat is being transferred from with the contact of the this sheaves basically. When sheaves are with contact with this the platform, the heat exchangers are over there. Okay, the water is flowing over there. Okay, then this solar photovoltaic modules are kept over there on the north wall. Okay, to supply a DC fan. Okay, and basically here the two trays are over there, one tray and second two tray, and one more schematic here. Over here it will be more clear. So water, and in fact this system was this is a kind of the hybrid drying system, or we have gave this name the heat exchanger evacuated tube assisted solar drying system. Okay, sir. So here the flow rate we have tested this under unload condition and the load condition as well. Okay, for the different flow rate, for the different water flow rate. Okay, and over this is basically the water storage tank. Okay, to maintain the hot water supply. And this is the DC fan. This DC fan over there, and DC fan, DC exhaust fan over there. These are running with the help of this solar photovoltaic modules. Okay, and yeah, this is more close. Just to see, these are the hot water tubes, and hot water tubes are in contact with this drying tray. Okay, wire mesh tray is over there. Wire mesh tray is kept over the over these heat exchangers. Okay, and like so, this is the solar collector evacuator type, number of tubes 20, diameter, material length, and other things that we are given over there. And yeah, moisture contained, drying rate, the same thing, whatever we have discussed. Yeah, this was equilibrium moisture contained. I was talking about this. This is a very important term, and in fact, this relationship we need to find for designing any kind of any solar drying system. This variability. Okay, so this is the equilibrium moisture contained that we can, and this is the T absolute temperature. R is the this constant. Okay, so and some exercise we can do the solar collector efficiency. We can easily find out with the help of the mass flow rate of the CP, the excess heat of the water, the outlet and the outlet and inlet water basically, and the total heat, total energy supply, solar energy supply over there. This is the overall thermal efficiency of the drying system. Okay, the energy or exergy analysis, exergy inflow of the drying cabinet, energy outflow, and the difference of that, the energy exergy losses, and the exergy efficiency we can EX around, and that we can simple formula. Okay, Okay. Now these days, basically this quality of the crop is also very important, that the colors and all. So A, B, L, these are the different color parameter. Okay, that we can easily calculate. We can and overall this delta I we can calculate with the help of the L, A, B, and the color of the dried product measured with the through the colorimeter. This colorimeter hunter and this illuminate this some because this the colors are measured with some specific illuminance only, because if the illuminance changes, its color also changes. Okay, so color difference change can be expressed with hardness is another important factor, because it's chewable. It should not be very hard, like it should be it can be easily chewable, right? So hardness is the highest power applied to the drive throughout the measuring, and this shrinkage factor is another important factor. Okay, so the same system we have tested basically. Uh, so this temperature and relative humidity and the solar radiation at the time, just to see over here this the maximum temperature we achieve over there, it was the 75 degree centigrade. And in fact, the 75 degree centigrade is sufficient temperature for most of the agriculture produce, for drying of the most of the agriculture produce over there. Okay, this is what this was the 10 liter, 20 liter, and 30 liters. So these are the different flow rate of different mass flow rate of the water through the conductive evacuated heat transfer, evacuated heat collectors. Okay, so this was done under unknown condition. We have so others work is now left. So this is